Hello everyone, we're going to go over section 3.1 examples. Number 1, the table shows the number of male and female students in a particular country who received bachelor's degrees in business in a recent year. So it has two parts, and this is a table that they're referring to, business graduates, this table. Question number 1, and I highly recommend that you use a highlighter because there are a lot of keywords that you need to identify to make sure that you get this right. So part A, find the probability. Again, create a fraction that a randomly selected student is male. Keyword also, given that the student received a business degree. The probability that a randomly selected student is male, given that the student received a business degree. What is after the word given is going to be what you have to look at. So it says given business degree. So this is these are the only numbers that you can use for part A. Any other number that you use that is not inside of this yellow box to create the answer, it will be incorrect. So given that this happened, how many of these are males? So that is 190,673 are males. So the fraction is 190,673. That is your numerator. Your denominator is the total for this box, 360,456. It's no other total number, nothing. Do not get creative because you're going to get it wrong. So now they want you to round it to 3 decimal places. So we're going to do an approximation. Get your Diego, Dora, get something to divide. 190,673 divided by 360,456. And we have to round it to 3 decimal places. Notice that we have 0.528 followed by a 9. So this is going to be 0.529. And again, with or without the 0 to the left. Next, find the probability. I'm going to change colors because we're using the same table. Find the probability that a randomly selected student received a business degree, given that the student is female. So, business degree, given is what happened, that is female. So, female is this row right here. These are the only numbers that I can use. I can only use this number or that number. Or 2 of those only. So, business degree. So my out of these ones, which ones have business degree? Find the probability that a randomly selected student receive a business degree given that the student is a female. So the denominator will be the total for females, and the numerator is going to be this one, the one that are business degrees out of the females. So this is going to be 169,783. So out of the females, these are the ones that are business degrees divided by the total for that row for females. And then we round it to 3 decimal places. So this is going to be 169,783 divided by 1,067,417. We're getting 0.159 followed by a 0. So 0.519 will be my final answer. Okay. Again, you might have to rewind this tape. It might be hard at the beginning, but if you follow what I'm telling you, it will be a breeze. Number 2. The table, which is right here, shows the results of a survey in which 250 males and 250 female workers ages 25 to 64 were asked if they contribute to a retirement savings plan at work. Complete parts A and B below. Find the probability for part A. Again, word probability means I need to create a fraction. I need a numerator and I need a denominator. That a randomly selected worker contributes to retirement savings plan at work, given, so this one is contributes, given that is a male. So male is what I will be highlighting. In this case, that will be the row because males is a row. So what that means is that the total for males will become my denominator, and my numerator is going to be the part that contributes. So that is 104. We round that to 3 decimal places. Again, it's not always 3. In this one, they ask for 3, but other problems will be different. So this is 0.416. 0.416. 0.416. Next. Find the probability that a randomly selected worker is female. Find the probability, again, keyword, I need a fraction. Female, given that the worker contributes to a retirement savings plan. So now what I am highlighting here is what after given. What is after given? Contributes. So that will be the total for that column will be my denominator. My numerator is going to be what is being asked before. Of those, how many are females? So that one is this number right here, 160. 160 of the 264. So clear, 160 divided by 264 equals 0.606. 0.606. Okay, that's it. Once you get the hang of that, it's a nice section. Next. For the given pair of events, let me see if I can zoom. For the given pair of events, classify the 2 events as independent or dependent. Finding that your cell phone works. Finding that your DVD player works. So the cell phone and the DVD players, they are independent. The one working doesn't affect, working or not working doesn't affect the other one. So the 2 events is not going to be part A because it says dependent, dependent. Okay, again, going back to the definition of dependent and independent. So dependent, they are dependent if the probability of one affects the probability of the other. Or in this case, the probability that, or the fact that a cell phone works is not affected that the DVD player works. They're 2 separate systems. So the 2 events are independent, and then we have to choose why. So the 2 events are independent because the occurrence of one does not affect the probability of the occurrence of the other. It's exactly what I said. Okay, so that's our final answer right here. Okay, number 4. For the given pair of events, classify the 2 events as independent or dependent. So driving 30 miles per hour over the speed limit, getting a speeding ticket. So this is the one that we had in the homework example, in the lesson example. So these are going to be dependent because if you go, the chances of you speeding, especially 90 miles per hour over the speed limit and getting a ticket, they are really quite dependent. So these events are going to be dependent. The 2 events are dependent, so it's not this one, it's not that one. The 2 events are dependent because the occurrence of one affects the probability of the occurrence of the other. So the answer is B. Okay, so let's see if I can fit number 5 in there. A coin is tossed and an 8-sided die number 1 through 8 is rolled. Find the probability of tossing a head and then rolling a number greater than 3. So keywords, I like to highlight keywords here, and that means that I have to write down the probability of tossing a head. So the probability of tossing heads is 1 out of 2 possibilities. And then rolling a number greater than 3, but this is an 8-sided die. So these are my choices from the die. These are the numbers. It can be any number from 1 through 8. And here, rolling a number greater than 3, so it's not including 3, so it's 1, 2, 3, 4, 5. So times 5 out of 8 in the outcomes in the sample space. So you multiply across. 1 times 5 is 5, 2 times 8 is 16. And here they want 3 decimal places. So unless they ask for a fraction, we provide decimal points according to how many they want. 5 divided by 16. This is equal to 0.3125. So we have to round it up, 0.313. Okay, so I'm going to stop here and then we'll do the other 5 in the next video.